waiting on Tabitha and Natalie Chase for Group 1's Lesson 6 review. I don't know where they are, but it is 9:15, the appropriate time we said to schedule this. I know we had a blizzard, but they should be coming. I know the blizzard hit us really bad here. Did you guys want to reschedule a group meeting, or could we do both lessons on Thursday? We'll wait for 3 more minutes before I start some. I'll make an edit on this video and just share that I did it. My friends, I know Tabitha has said she would do the alternate activity because of work purposes, but that's all I know about. Natalie, I haven't heard anything. Let me re-invite them. I'm just busy browsing stuff. Dang, it is cold. Absolutely freezing. Oh. Two minutes left. I don't know where they are, but as far as I knew, they said they would be here, but I'm looking through my emails. I think New Hampshire is still getting hit. Do you guys want to reschedule the group meeting? This is Tabitha talking, because I know we got hit by the huge storm. One minute left. Okay, well, they're not here, but I'm just going to start. We have record that we did this. Right? Lesson 6 preparation assignment. We had to do the reading, and we had to fill out some notes for everything about this subject was about the sampling distribution, also about the sample mean, and we kind of had to explore what X bar is, as far as, and also the central limit theorem. So we kind of got through some of those through the reading. And we ended up having to, also for our group project, we had to do we had to cut out these little boxes, which were on our assignment sheet. We had to randomly draw them out of a hat and kind of see the curve for our assignment. But since my group's not here, I'm just going to go ahead and do it by myself. Actually, I think I've already done that. Yes, I did. I did do it. But I was going to go over the answers with my group. So, just to go over, what is the sampling distribution? The distribution of the definition of what is sampling distribution? It's a distribution of all possible sample means, or X bar, X with the bar, of a particular sample size, graphed and plotted but many times. The mean is equal to that mu, and the standard deviation is the sigma divided by the square root of n, the number of samples that you obtain from your data. Next question, what is the shape of a sampling distribution of a sample mean when the data is normally distributed? The answer is a normal distribution curve, so a bell shape. Number 2, what is the shape of a sampling distribution when the data is not normally distributed, but the size is large? The answer is a normal bell-shaped distribution curve. And how does the shape of the sample distribution change when the sample size is increased? I also got a normal bell-shaped distribution curve, but I'm not really sure if that's the right answer. Let me look here on the answer sheet to that week preparation. Just kind of looking at the answer key. Sorry, I don't normally look at the answers until, okay, normal, so approximately normal. If it's not normally distributed, but the sample size is large, you can approximately say it's normal. And then number 4, the one I just answered, the one that I wasn't sure about. The sample distribution more closely approaches a normal distribution, and the standard deviation decreases, meaning, and the mean is unchanged. Okay, so I said it was a normal distribution, but it looks like it approaches a normal distribution, and the standard deviation goes down. So I didn't quite get that answer. It's good to know this. Standard deviation goes down. What is the difference between the central limit theorem and the law of large numbers? I said the central limit theorem says if the sample size n is large, then X bar, or the mean, will be approximately normal or normally distributed. And it was the answer says. The law of large numbers, that one says, is that the sample size n gets larger, the sample mean, or X bar, will get closer to a population mean, or a mu. Answer, the large numbers. The law of large numbers states that a sample size increases n. And so as n goes up, standard deviation of the sample mean will go down and get smaller. Probably very important to remember that. So as sample size increases, the standard deviation of the sample mean will go smaller. The central limit theorem says if the sample size is large, the sample mean will be normally distributed. Good to know. All right. X bar. When X bar is normally distributed, if pair population is normal, no matter how many observations there are. If not normal, it will be approximately if the sample size is large, and the sample size of about more than or equal to 30 is what we said. It means it's going to be approximately normal. So when x bar is normally distributed or sample size n is large, x bar is normally distributed if the data were drawn from a normal population or if the sample size is large. Yeah, that's kind of the gut I got to, yeah. So just written that differently. All right. Next up, the part 2. Randomly select 5 of the 30, compute the mean. I did that. I can show you. I got 45,540. So if we look at the answers, after picking out 5 of these guys, of the little samples from our bag of 20, I think it was, no, 30, I ended up having like an average of about there underneath the bar. And that was the mean. That was the value of my sample mean from part A. Does your sample mean appear to be unusual? Not really, because you'd expect it to be close to the average sample mean. Or in other words, you'd expect it to be like right there in the middle, the average mean. Compare your question. What do you notice? In practice, you only get to see from the means of samples drawn. Well, I would have to compare it to my teammates, but I don't have any teammates right now, so I would assume that I would get closer around those answers. I would get nearly the same thing because they also took out 5 random ones and they ended up getting that. 8A, what is the size distribution of sample means for all such samples? Normal distribution, I said, or a bell shape. What did they end up getting as a group participant? Sorry, I'm just trying to sift through my psych notes. Okay, here we go. Okay, normally distributed. Haha, we're correct. Okay, part 2. B. How do you know the distribution of the sample has this shape, although the shapes are normally distributed? Parent population is normally distributed. Okay, I probably should have said the parent population is normally distributed. I said all of the shapes are normally distributed, but I think that's what I meant when I wrote that answer. So parent population, normal distributed, then that's how you know your sample mean also is normally distributed. What is the mean of the sampling distribution of the sample mean? Scores for all such samples. I got it's equal to the sample mean of the parent population, which is 529. They got the same. D, what is the standard deviation of sampling distribution of the sample mean scores of all such samples? So you had to know that sigma divided by the square root of n samples is equal to the standard deviation. So in other words, 113 divided by the square root of 10, I ended up getting 35.734, and that was the right answer as well. Okay, I don't think I had any other questions. It was rather straightforward. I was a little confused about the central theorem and the law of large numbers, but I think I kind of understand a little more than I look at the answers. As the number sample goes up, the standard deviation will go down. And the central limits theorem, as if the sample size n is big, the x bar or the sample mean size will be normally distributed or approximately normal. Okay. Well, that's my preparation assignment and group assignment. The homework. From the practice problems. So what is the difference between the central limit theorem and the law of large numbers? So I said it was A, and that was the right answer. Central limit theorem describes what happens to the shape of the distribution of the sample means. when the sample size is large. Remember, shape normally distributed, the sample size has to be big. The law of large numbers describes what happens to the spread of the distribution of the sample means when the sample size is large. So the spread versus the shape. Shape being central limit theorem and distribution being the law of large numbers. Which the following gives the best explanation for the law of large numbers? If the sample, I said C, if the sample size is large, the sample mean X bar will be close to the population mean U. Yes. Has nothing to do with the shape. It has nothing to do about the 95, 99.768 rule. And the parent population from which the data should know, that doesn't make it. Suppose the mean internet usage of BYU Idaho is 30 hours. What is the shape? I said it was skewed right, I said it was skewed right, but I think the answer is, looking at there, skewed right, yep. So what was the mean of the standard? I said 30 hours. What was the standard deviation of the distribution of the sample means? I said 2 hours. And then I go on to another one. BYU Idaho students 30 hours a week of a standard deviation of 4. Distribution is rightly skewed. Now they ask what was the shape of the distribution of the sample means in this one. They said it was normal. Because the random sample of 4 students was surveyed versus 100. The second problem had 100, which is why it was normally distributed. But the first question said, oh, we're only going to take 4 students out of a group, which is not many. So that definitely made a difference. What was the mean? It was 30. What was the standard deviation? It was small. It was like 0.4. Length of human pregnancies. Use the answers. What was the normal shape? Normal, I said. The mean of the distribution of that problem was 266. The standard deviation was 2.921 days. Is the mean of the distribution means greater than, equal to, or less than the parent population mean? I said it was equal to, just because standard deviation of the distribution means greater than, equal. I said the standard deviation was less than what the standard deviation of the length of normal human pregnancies. So, in my own words, central theorem, limit theorem, I've been kind of explaining that in the law of large numbers. And again, another explanation. Basically, when talking about the sample, the law of large numbers, going back to the law of large numbers tells us that the sample mean will be close to the mean of the population as it goes up. That's what I have written from my previous notes from the first subject when we first got introduced to it. The sample mean will be close to the population mean. Versus the central limit theorem, which was this subject, which I wrote. If the sample size n is large, the sample means distribution will be approximately normal to that bell-shaped curve. Again, distribution versus shape. So that's what I got. If there are any questions or any kind of concerns, I will be sure to address them in the appropriate threads. I will thank you for watching, and I will talk to you guys and see you guys later. Thank you very much. Have a nice night.